Alright, so lesson 9, configuring hardware and storage. And again, this is one of those where we want to be really careful. We're going to be talking about some stuff that you probably should not do in the cyber range, and you should be very cautious about doing if you do it on your own machines. Alright, so moving into that. So, one of the reasons I hear from people that they're uncomfortable moving to Linux is they feel like there's going to be incompatibilities, that there are going to be hardware problems, they're not going to know how to solve them. And there's some legitimacy to those concerns. But it's not as bad as people think. In fact, most modern builds, so Ubuntu 18 and those sorts of variants, really pretty strong and work really well. In fact, on my primary Linux machine, it installed, it works, it recognizes everything except the fingerprint reader, and in fact, in many ways, works considerably better than most of my other machines. So I think that some of that is unfounded. That said, that when you're in the command line, things can be a little different. And of course, in this class, because we're thinking about it from an administrative standpoint, we're kind of focused on command line. So a few things to just kind of get right out there. We want to talk a little bit about different hardware, and hopefully some of this is just review, but in case it's not, let's remember that the CPU, our central processing unit, is what's the brain, the decision maker. It's a chip or a set of chips mounted on the motherboard and does all of the mathematical calculations, if you will. So all of that binary decision making that occurs in the processor or processors of other devices. So for instance, video cards now have pretty big processors in them as well. Typically, most of our processors these days are multi-core. What that means simply is that you might have only one physical processor chip, but that processor actually has multiple processing cores. You might see that it may have 2, 4, 8 or more processing cores in a single chip. And of course, if you have multiple chips, you may stack multiple processors. So you may have 4 chips each with 8 processors. And that would be a pretty hefty machine, to be certain. So when we're looking at processors, we can run this LSPCU. Yes, let's try that again. LSCPU. I had it right the first time. My fingers wanted to do it. And you can see in this case, it's a pretty small little processor. And that's because we're running in the cyber range. Certainly if I were to run from one of my other machines, you'd see significantly more. So you can see this one, for instance, when I ran this command on my Ubuntu Mac, that's simply just a virtualized processor. You can see in that case that I've got it virtualized to appear like a much bigger processor with multiple cores, and so that's a little bit different. So you can see there, it looks like a much bigger processor than, say, down here when we're looking at a single 32-64-bit system. So the point here is that processor makes a difference, obviously. The more processor you've got, the more processing that can occur. And if you have multiple processors, then you can process things simultaneously, which tends to make operations go much, much quicker. Firmware, we definitely don't want to mess too much with firmware. So you can do this DMI code. Oops, get down there. DMI code, let's see what we get. I don't know, we may not like it. Yeah. Sudo DMI let's try that. And you can see some things. Obviously, any machine, whether real or virtualized, is going to have firmware associated with it, a BIOS, UEFI. But you can see here, we can see a little bit about it. I wouldn't expect you to understand what most of this stuff means, but let's see if we can scroll through it a little bit. We can point out a few things. I really should have left that so I could control it a little bit better. I apologize. So you can see that in this fact, we're running Zen on Amazon. Zen is just a virtualized, it's a hypervisor. And so you can see that this is running on Amazon's hypervisor that they're using, Zen in this case. And you can see information about the circuit and the socket and system. Again, not that I'm looking for you to understand a whole lot of these things, but as you get into it, these things start making more sense to you. And right now, it's really just about knowing where to look for these things. So RAM, again, this is one you will find you use. So if we do free, we can see what we've got. And let's make that a little bit easier to read by making it just a hair smaller here. View. How do I zoom out in this one? I can never remember from version to version how to zoom out. I'm not going to be able to find it, I don't think. I'm just going to keep banging on it and never figure it out, am I? Let's see, maybe it's, maybe? No, nope. All right, well, we'll just leave it as it is. One of these days I'll remember. But you can see that how much memory you've got, so in this case 2 gig of RAM, and then how much is in use and how much is actually free. As you might imagine, that's particularly important, particularly when you're dealing with small systems like this. When you have very little RAM, you want to be very, very cautious about how you run things. It's interesting to recognize, though, that with only 2 gig of RAM, we've got this application running. We've got an operating system that's graphically based, internet support, all the bells and whistles, and it's reasonably snappy. It's kind of quick. You would have a hard time running a Windows 10 environment in this same single processor. 2 gig of RAM kind of world. So you can definitely get a little bit more out of a Linux machine often. IRQs, this used to be a really big deal way back when I was younger and working on them. This was this idea that computers had to communicate over a single pathway, if you will. And so if you didn't have the pathway wasn't open, if it was in use by another device, then things couldn't pass back and forth. So you might be trying to communicate to your modem to get to the internet, but unfortunately your sound card is on as well, and they're using the same IRQ, and so one would work and one wouldn't work. We don't have much of that. We kind of deal with PCI these days, but it's good to remember that the concept is still out there. Again, so boot disks, it's set in BIOS or UEFI, decides what you see. So when we boot, we typically see our primary device. So if I'm a Windows machine, typically the boot disk is going to be C, and I'm going to see Windows boot up. With Linux, it's just a little bit different. And if you're multi-booting, then you want to kind of understand what's going on and recognize. Again, it's a lot of vocabulary stuff. Cold plug and hot plug, very important to know the difference between these, because you'll hear this in reference to a lot of different things. But in our case, we're going to talk about, think about USB devices. In theory, it's a hot plug device, meaning I can plug a USB in, pull a USB out, and not fry the operating system on the USB. Although in reality, we've discovered often you have to eject it first. Ejection simply means, in a case like a USB drive, that you're stopping the operating system from writing to that drive before you pull the drive out. It's still technically a hot plug device. It's just that if you're physically moving data at the time you unplug it, that could be bad, right? So that's the big difference. Hot plug simply means that we can be on, but that doesn't mean necessarily that we don't have to unmount the system first. Cold plug means we actually have to be physically disconnected. So your primary hard drive is a good example of a cold plug device. You would not want to reach into a running computer and pull that hard drive out. That would be bad on so many levels. So we saw the LSPCI, and as you can see, there's a couple of different ways you can use it. So if I wanted to get a lot, I could say something like LSPCI, and let's take a look at verbose. All of a sudden it stopped typing. There we go. Now let's use verbose, and let's pipe that to less, because it's going to be verbose, right? And we can see that we're running a Red Hat system, and we can see that what's going on right now as we dig through these. You know, you can see all of this stuff going on. I'll go a little faster. And know what each of those is doing on each of those PCI devices, right? So that's kind of what we mean. And of course you can do mod info. So if I wanted to cat which I shouldn't have a floppy, but as you might imagine, we've got to go looking for it and take a look at it and see what we've got. If we wanted to know what things we could do, we could always like ls sbin, right? Let's do that one more time. There we go. Ah. So I'm just typing randomly at this point. I have no idea what I'm doing. LS has been. What am I doing wrong today? I think my brain must have been disconnected. Let's try this. All right, so ls, right? It's got to go look in sbin. There we go. And we can see all of the stuff in there. And then if we ls sbin / mod info, I can't get in there. Sbin. My brain, it's just not functioning today. All right, so whoever is ahead of me today, send me an email and tell me why I'm an idiot. I don't want to waste any more of your time. It'll probably hit me 3 slides in. Yeah, so the mod info is I'm going to look what's inside. I just thought I could actually look and see, but I think you have to know what you want to look at in the mod info. You know what? Now I'm just frustrated now. So let's look and see. How would I answer my own question? Linux mod info. I think I need to know what I'm looking at inside there, right? So let's take a look at this. So we'll go look at here. Mod info. Yeah, so you got to know what you're looking at. There we go. That makes a lot more sense. So what might we actually find in our mod info? What module names would we be able to find? Because we're probably not going to find a Bluetooth. What in mod info? How could we find that out? Yes, no, we already know this. I want to know what's in it. Show info. There we go. So if I want to know what's in it, I could use mod probe. Is that right? This has been mod probe. So I'm struggling through this because I want you guys to see that I don't know all of the answers either, and there's really some value in digging through and trying to find, all right, so how do I answer my own question? All right, so well, that didn't help. Oh, all right. Well, clearly I'm not going to get what I was hoping for. But you know what? That's all right. It's good for you guys to see that I don't know what I'm doing all the time either. That's pretty funny. All right, well, I'll try to see if I can't figure out what I'm doing. No doubt somebody will jump right in and tell me what I'm doing wrong, and I'll be able to put that out there. So that'll be awesome, and I'll feel like a real idiot, and that's okay. I'm good with that. So USB, let's get on back on track here. So if we want to know more about USB, for instance, we can give me my module, my ls. USB, and we won't get much because there isn't one in here, but if we were using on one of our physical machines, we would be able to do that. And while I'm sitting here in the background, let's VM Let me spin up a physical machine here. I'll go back and visit some of these in my virtual machine here. Let me get this fired up. I know you can't see what I'm doing right now, and that's okay. I'm just going to set that over here and power up the Ubuntu box. When that comes, we'll circle back around and do a few of these. Let's see here. So to capture that, I need to go to, I want to create a new window, window capture. Alright, that's great. And let's see, where's my Ubuntu box here? Having a hard time finding it. I got Chrome, PowerPoint, that one maybe? No, that's OBS. That's not going to do us any good. That's not going to do us any good. That one maybe? No. There it is. All right. Yay, look at us. Now we've got a Ubuntu box. I can pull that over here and we can take a look at that. We'll throw that one down there. Make him a little smaller. That way we can look at both of them. So once this comes up, we'll have a nice little Ubuntu box. We can circle back around and try some of these things there and see if that works any better. Do you like how I'm just kind of winging things as we go? You can tell I was well prepared coming into this today. All right, so disk devices in the dev directory. So remember that we talked about disk devices, and we talked about this idea that in the legacy drives we might see HD drives, and typically in most drives these days we're going to see these SD drives. And so these we actually should be able to see here. So if I look in the /dev directory, we can see that I've got a bunch of stuff in here. Alright, so we can see all the stuff that's going on in the dev directory, and we should be able to dig through here and find our hard drives. I can't remember how they do them, SDs in Amazon. Meanwhile, my Ubuntu machine is not booting up. It's going to be one of those days. Let's see if we can restart that thing. Let that go crazy. And as we want to look at these things, so we can look at them, and of course we want to do the SDX. So if I was to see, I'd really like it if my Ubuntu is broken. All right, well, how about a Kali box? That'll work. We'll fire one of those up too. So you can't see my desktop here, but I've got like half a dozen machines all spinning up now. I'm trying to spin up a Kali box to see if maybe we can get that to work, so that I can show you some of these windows. There we go. Kali's got the same problem. I think my issue might be that there's something going on with my virtual box. Because none of these machines are booting up clean today. All right, well, let's dig into it from over here in our console, now that you've all been thoroughly entertained by this idea that I don't have any clue what I'm doing. So if I were to say dev SDX, find my slides again here. Let's go and look at it this way. All right, so here are my outs. You can see that. There we go, X. That's why I couldn't find them. So if I wanted to know in my Linux running on Amazon, they start with XVDAs. That's why I couldn't find them in the S's or the H's. So X is this. I don't know if it's specific to Amazon or if it's specific to Zen, but that's where they have this. Yep, come on, Kali. Kali might actually boot. That's where your drives are actually mounted. So you can see here's a mount system. It's dev XDA. Hey, all right. Is it? Did I change it? You guys can't see what I'm doing. I'm over here trying to remember my Kali password. I'll let that boot. So that's how you can if you use your find mount, you can see what you're mounted at. Remember that find mount is also going to show you not just hard drive mountings, but it's also going to show you system mounts, because recall that everything is a file in Linux, right? So a hard drive is a file, and what we typically can think of as a file system is a file. So each of these things is mounted, if you will. So let's dig a little deeper into this mounting thing, since clearly none of my drives are going to let me get in. Hey, look, this one actually finally booted up. Right on. All right. So now we can look at them. All right. So let's hide that one right there. Is that the one we had? No. Where'd you go? Is it that one? Nope. That one? Nope. I'll find it. I only have like 100 of these things open right now. There we go. All right. So down here you can see in my physical box. Let's go ahead and open up. And now Kali's finally booted too. I guess it just wanted to take a really long time. They're taking a really strangely long time today. All right, well, I guess we'll just ignore that for a while. There we go, come on. Yeah. All right, I'm officially done with that. Get rid of that. All right, so let's just stick with what we got. And for those of you going, what the heck is he doing? Remember, you can watch on double speed, you can fast forward, you can ignore me looking like an idiot if it's not entertaining you at all. So when we configure our hard drives, so take a look at this. Let me see if I can make this a little bigger for you for a second. I want you to look at this picture. Where are you? So you can see here that I've got this image. And this is, if you will, sort of like a physical hard drive image. So it helps to think of a drive kind of like this, as this physical thing. Now, we typically use GPTs, but this might make more sense for you for a moment. So on the very first sector of the hard drive, we've got this master boot code. And then after the master boot code comes each of the things that it needs to look through. So we have these partition table entries, which says, hey, I've got this partition, it does this thing, and maybe I have multiple partitions, and each of these partitions looks like, if you will, a physical drive. Right? We call them logical because they're not real, right? You still only got one physical drive, but as far as the operating system is concerned, it looks like a bunch of smaller physical drives. All right, and with the newer systems, it works similar. The big difference is now that this protected MBR stuff it gives us a little extra security. It keeps us from accidentally overwriting these things quite so easily. But again, you can see the same kind of idea is we've got these partitions, and these partitions look like physical drives to the operating system. So that's how we can have an operating system appear to have multiple drives, and that's not too different from what you're seeing when you look at, go ahead and move this back down here. When you look at these things, it's not exactly the same, but conceptually this idea of the operating system sees things as separate parts and moving back and forth between them. So let's see if this makes it any better for you. So when we look at a partition, that's this thing here, right? We're just going to look at a primary partition. When we look at a partition, what we've got is we've got this primary partition. All right, and it's a section of drive that logically acts as a separate drive, meaning that you can make it look like a bunch of little drives, and each of those little drives looks like something totally different. So primary, this is usually where your boot is, right? So if I was running a Windows machine, my primary might be Windows. If I was running a Linux machine as my primary might be a Linux machine. And then each of these are my multiple boots. as. Get rid of those two as's. So if I dual boot, or like I'm gaming and I have a Windows machine and a Windows gaming and I want to dual boot between them or something like that, that's where these logical partitions come in. Right. So if we want to take a look at this, and again, this is why I was hoping these other things might work a little bit better. When we look at these, dev xvda1, we can see that it's there, it's physical, we can actually mess with it. It's a real honest to goodness file, right? I'm not going to try to read that file, right? But it's there. Right, and if I wanted to list them all, I could certainly say something like ls dev. I'm still only going to see one, xvd, and then I could put an asterisk, and it would show me all of them. So I've got an xvda and an xvda1. Hey, there's actually one more than I thought. So I can see I actually have two physical appearing drives in my machine. And then I could use fdisk to take a look. This is one you want to be cautious with. I'm going to run it. So if I do fdisk, xvda1, yeah. I wonder if I have to sudo that. Yeah, okay. So I can't see a whole lot there on that one. When I were to change this, I can see a little bit. So I can see where it is. It's a boot device that has a start and end. Basically tells me how big it is, its ID, and the system that's installed in it. Okay. Do be careful with fdisk commands though, because if you do other things with fdisk, you can make it explode. Right? And so now we're going to talk a little bit about making it explode. We're not going to run them. We're just going to mention that fdisk utility. When I just look at it, that's cool. But if I use these other commands, like I can blow up my drive, I can burn it out, right? I can like reformat the drive, erase the system from it. That would be bad, right? I can modify the partition sizes if I need. Like say I had a Windows machine and a Linux machine, and my Windows machine was too big, my Linux machine was kind of small, so I could expand and contract those devices to make more space. I also can use the parted. Again, we're not going to do that, right? So use the parted command, you can actually get similar control. You can actually run parted and get into the system and do stuff. Don't do it. But parted is the more common command now for wanting to play with your with the format and the partitions on your drive. So just some very general things. This is great stuff if you want to build your own machine, but again, please don't do it here in the range. File systems. So Linux file systems, as with Windows, there are multiple file systems, and the type you choose kind of depends a bit on the version of Linux that you're running and the purpose of it. The nice thing about a journaled file system, which is what these three are, is that it keeps up with pending changes, meaning it's got this pre-write that says, I'm going to make this change, I've made that change, right? So if something happens during the change, you can use that journal sometimes to fix the mistake, usually by rolling back or completing the change. So it says, these are the changes I'm going to make, and then if those changes fail, you can go in there and say, all right, well, let's fix them or change them. And it's usually a quick do it. Again, please don't play with this here in the range. I don't want to get yelled at again. But these are the files that can do it. Feel free to install your own machine and break it to your heart's content on that. So LVM is how we look at these things. Again, we're not going to do it, but LVM actually lets us dynamically deal with volumes. Why would we do that? So if I'm running multiple machines, multiple volumes, it's really hard to expand and contract those volumes. So if I find out that one machine needs more or less space, because drives don't write in a linear fashion, right? So if this is my drive, we tend to think that when we write data like this on my drive, all nice and pretty, all lined up. That's not really the case, actually. Typically what happens on a drive is it writes a little here, and it writes a little here, and then maybe it writes something here, and then maybe it'll write something here, and then it maybe writes something here, and then maybe it'll write a bunch in a row right here, and then it'll write something over. You get the point. So if I want to make this drive smaller, right, if I decide I want to make this drive smaller and get rid of everything over here, as you can see, I had a bunch of good data there, and now it's gone, right? So we have to actually physically move that data before we can change the drive size, and that's hard to do. LVM lets us have a little bit more of that. Also lets us create these snapshots, which are brilliant, which are basically saves, backups of what the drive is supposed to look like, but it can be a little challenging to set up. Optical discs, for those that still use them, think Blu-ray, CD, DVD, that sort of thing. You usually can find them in the media folder, which is usually the M&T. We shouldn't have any of those in our range, so I'm not going to bother looking. Again, don't do this in the range. But an FSK will run like that. Was part of the problem we just saw a minute ago, is that was running in the background on both of my machines. I was trying to spin up to show you. As it turns out, it's actually fairly common. It's useful. What it does is it looks at a file system and it tries to find mistakes in the system. Used to see these really super common, like the tiniest little brownout, and all of a sudden your machine was running FSK again. It's not quite that bad anymore, but it's still pretty common to see this. Again, you would never want to do this on a mounted file system. So I could absolutely do this on a, like if I had a C drive and a D drive, or an XDA, or an HDA, an SDA, and an SDB, something like that. I could run it on the SDB if my primary was an SDA. I wouldn't want to run it on SDA. That would be bad. All right, now some commands we actually can use. So we can actually look at things. So for instance, let's take a look at our drive here in our Amazon account. You see our CyberRange account. Let's take a dev. It was at XDA, XVDA. Oh, it's right there on the slide even. XVDA1. Totally harmless. Recall that H command I did so that I can see what's going on. If I wanted to do a DF, H to see everything. I can see all, not just the mount point, right, the hard to physical drive, but I can actually see all of the other mount points and how much space they're using. Super useful, right? So I can look at this and go, oh, look, dev is only taking 1% of my space. I'm in good shape. I'm in great, not a problem. And of course, I can apply this DU if I really want to get in there, right? So DU max depth equals, let's go 5. H, see if I got that right. And now I can see all the way down into these little tiny subdirectories, right? And I can see how much space every little tiny directory uses. And that's a really great way to try to find out if something's going on that's weird on my system. So for instance, let's go down here to the bottom, something obvious. Other way, scrolling backwards. For instance, let's say that I know this file, right? So the local share icons high color should be tiny, and 16K, that's really small. That would be a really good place to hide information. So if I were to run this and see that it was actually 6 meg, a gig, something crazy, I could go, hey, something's writing into a directory it shouldn't be writing to. That directory is way too big. And so something's going on there. So you can see there could be a lot of really good reasons to get deep into that information and start dissecting the drive. Again, don't do this. Just more on this idea of resizing drives. We can actually enlarge and shrink using resize as well. Let's just make it bigger or smaller. Again, we're not going to do it. Just remember that you've got these sorts of tools there. Mounting and unmounting. So for instance, we unmount USB drives before we eject them. We would not typically want to unmount our primary drive while we were reading it, but umount is actually really pretty useful, particularly if you've got a USB drive running. Umount F would allow us to force it. So sometimes we see this problem where a drive doesn't want to eject. So the F says, nope, stop everything from reading and writing to that file. Yeah, it may burn up the drive, it may not, but we need it to stop. That's the safest way to do it. All right, just a couple other reminders. You've got this proc mounts, proc partitions, and the LSBK, which will show us everything we want to see. Take a look at LS. I'm not even sure if this is installed in here. LSBLK. Yeah. All right. So you can see that XDA is a physical drive. XDA1 is the mount point on the drive. Right. So kind of useful, easy, and fun. So sorry to be all over the place with this one today. For those of you who've never had a class with me, now you've fully experienced the in-class experience, because it's totally like that all the time in my classes. I kind of go down a rabbit hole and realize I have no idea where I'm going. Like I said, feel free to watch again, figure out what I screwed up, and email me. I'd love to know where I'm messing that one up. I'm sure I'll find it, but it's going to take me a while to get there probably. Hope this was fun. It was fun for me, and you got a midterm coming up, so let's all start getting ready for that. Be sure to look at the information I post for that. Good luck, everyone.